Okay, so the last video, I just want to kind of talk about what's being shown here. And you should see, so I've just made the map the full screen. And in the upper right here, you have two layers. So let's uncheck them to kind of make them not shown anymore. And so the idea is you have this base map, and one thing you'll notice is that the base map, if you move kind of to the west by dragging to the east, if that makes sense. You're kind of like spinning the globe, and you can kind of do this infinitely, but you can't spin north or south infinitely. It's just pretty much like spinning a globe around that allows like endless lateral movement. And so there's your base map, and then the idea is that you can draw layers on top of that base map. So here we have the graticule that we're laying down, kind of like a transparent layer um, on top of this base map, and then we're going to put the Tissot's indicatrix, I believe, on top of that. And so we've got one layer on top of another layer. So graticule is just a jargon word to mean like lines of latitude and longitude. You can think of it as the graticule as the kind of the geographic graph paper that we use for kind of drawing on maps. And what this is going to show you is the some of the kind of stretching that happens when with the Mercator projection. So if you zoom into the equator, you'll notice that these are kind of perfect squares because they're, I think, 10-degree latitude longitude lines. And then as you move away from the equator poleward, you'll see that the lines of longitude kind of remain parallel, and kind of the spacing doesn't really change, but the lines of latitude get spaced further apart. There's reasons for the Mercator projection that we will talk about later when we get into vector data sets. It allows you to draw rhumb lines, lines of constant bearing that are really helpful for navigation. If you've ever sailed and tried to follow a bearing, or used a boat at all, that's kind of the idea behind the Mercator. But it does introduce this distortion. So just again, you can turn these on and off with the check mark. You can also change the opacity from kind of opaque to transparent by using the sliders. The Tissot's indicatrix is this idea by a man named Tissot, a quick method, visual method to kind of examine some of the distortion that's introduced by projections. And so the idea is that these circles are all the same, represent the same um, area. They're all the same shape. They're circles, and they represent the same area of the world, right? So they each represent the same geographic area. And what you see on the Mercator projection is that along the equator, technically it's tangent to the projection, meaning that the equator is where the ellipsoid touches the projection surface, and that preserves scale. So the equator, the circles all look pretty good. They're all the same size, and they're kind of all the true size and shape of this kind of geographic circle. But then as you move polewards, you'll see that the circles appear a little bit bigger, and the same amount of geographic area is being represented symbolically by a larger symbol. Does that make sense? So the area up here is the same as the area within this circle, but the size of the circle used to depict that area has gotten bigger. Is that fair? And so what that is showing you is, and as you go towards the poles, it gets to be kind of absurd, right? The circles are quite big. And so what that is showing you is how this projection dis distorts the representation of area as you go polewards. And another kind of fun way to see that is this true size of sight that I'm going to drag up here. And I'm going to click that. You can follow that video if you want. But the idea is that this is going to allow you to kind of drag, there's the US as it appears on the Mercator. And as I drag it to I'm sorry, this is, yeah, as it is depicted on a Mercator in its true geographic location. If I move this to the equator, it's going to shrink a little bit. This becomes, pretty true if we say Russia, and there's Russia. It looks massive. It is a pretty big country, but if we drag it to the equator, you can see that it's actually um, a bit smaller. It's still a really large landmass, but it's not quite as massive as it looks up here. Is that fair? So this is just kind of a nice visual technique to look at some of the distortion. And I think because we are going to be using this Mercator projection to look at a lot of results, I just want to make sure that you kind of understand the salt that you're going to need to kind of like take that as when you're using the Mercator to look at the mid-latitude and kind of more poleward locations. The area that you're seeing on the map is going to appear uh, kind of appear greater than it would be on a globe. Is that fair? So that's all I wanted to get at there.